All right. Hopefully you've had an opportunity to do some of the review problems before you're watching this video. I'm going to go over the solutions to each one of the slides in the review. So if you need to pause it, absolutely pause it. You need to rewind it, see it again, please feel free. So the very first thing says to multiply using any method and then state the degree and the leading coefficient of the result. So I'm going to use the extended distributive property here. And what that means is I'm going to do 3x squared times x and then 3x squared times negative 3. And then I'll come back and do negative 5x times x and negative 5x times negative 3. And then what I'm going to do last is the 4x times the x. Sorry, the 4 times the x and the 4 times the negative 3. So that's the extended distributive property. So in my first multiplication, I have 3x squared times x. That's going to get me 3x cubed. Then I'm going to do the 3x and the negative 3. That's negative 9x squared. I'm going to move on to the negative 5x. Negative 5x times x is negative 5x squared. And then negative 5x times negative 3 is positive 15x. I'll move on to the 4. So then I have 4 times x, which is 4x, and 4 times negative 3, which is negative 12. And now I can combine my like terms. There's only one x cubed term, but I have two x squared terms, so negative 9 and negative 5 is negative 14x squared. There's two linear terms, so I'm going to add the 15 and the 4, and I'm going to get 19x. There's only one constant, so I'm going to put negative 12. So that's my resulting polynomial here. And it has a degree. Remember, degree is the highest exponent, and that looks like a 3. And the leading coefficient then is the coefficient of the term we pick the degree out of. So if we pick the degree out of this term right here, that implies that the leading coefficient is also 3. Okay, so for the next one, it says multiply using any method. And I see that I have a square. So I'm going to use the binomial square theorem here. If you recall, that says if I have something that I'm squaring like that, then it's going to equal a squared plus 2ab plus b squared. Okay, so I'm going to take my first term and square it. I get x squared. I'm going to take my two terms, which is the a times the b, and multiply them together, and I get negative 3x. But I still have to double that. So that becomes negative 6x. And then I'm going to square my second term. So I'm going to square negative 3. That gets me positive 9. Okay, so I've multiplied it. There's my resulting polynomial. I find the highest exponent, and it looks like it's a 2. So the degree here is 2. And, we also call that a quadratic. And because I found the degree in this very first term, the coefficient of the first term is 1. So my leading coefficient is 1. Okay. So for the next one, I can still multiply using any method. I'm going to do the distributive property, but because we have 3 terms here, I can only multiply 2 together at a time. So I'm going to start with these first 2, and I'm going to multiply those together to start. So I'm going to do 2x times 3x, and I get 6x squared. And I'll do 2x times negative 5, I get negative 10x. And 4 times 3x, and I get 12x. And then 4 times negative 5 gets me negative 20. Now I haven't used this x plus 2, so I have to remember to keep writing that till I use it. I do have like terms here in the middle I can add together, so that's what I'm going to do next. 6x squared plus 2x minus 20. And I still have that x plus 2. And now, just like that first problem I did, we're going to use the extended distributive property here. I'm going to do 6x squared times x, and I get 6x cubed. I'm going to do 6x squared times 2, so that's 12x squared. And then I move to the 2x. 2x times x is 2x squared, and 2x times 2 is 4x. I'll move on to the negative 20. Negative 20 times x is negative 20x, and negative 20 times 2 is negative 40. So I can combine my like terms. I only have one x cubed term, so I'm going to write that. I have two x squared terms, and I'm going to add them together. So that gives me 14x squared. I have two linear terms, and I'll add them together. for a negative 20. So that's going to get me a negative 16x. And I have one constant, which is negative 40. So that is my resulting polynomial. And if you look at the term that has the highest degree, you'll see that the highest degree should be a 3. I made a mistake here. So let me go back and fix that. Okay, that should be a 3. That was 6x to the third. So the degree is 3. And remember, we can also call that a cubic polynomial. And I found the 3 on this first term here, so that implies that my leading coefficient is a 6. All right, so next up, I've got a rectangular piece of metal with the dimensions of 12 by 15. So I'm going to go ahead and give that a draw. Okay, so this whole piece right here is 12, and this whole dimension here is 15. Squares of a side length x, we don't know how much, but we're cutting off from each of the corners. Okay, so we're going to cut off an x here, and we're going to cut off an x here. This is also x. We'll cut off an x here, and we're also going to cut off an x here. Okay, the open box is made by folding the remaining edges. So if I fold along these dotted lines I'm making, you can see that it's actually going to reduce the surface area of my base. Okay, it's no longer going to be a length of 12. This piece is actually now 12 minus 2 x's, because it was 12, but we cut off an x here and cut off an x here. And then this piece was, the whole thing was 15, but we cut off x and cut off x. So this piece is actually 15 minus 2x. So we've got the length and the width of our box. The only other thing we need of our box is the height, because we're looking for the volume. So the volume equals the length times the width times the height. So if this is the dimension of the piece I'm going to fold up, it's x by x, then that means my height is going to be x. Okay, so I'm going to start with the length. We'll call that this one down here. I'm going to reorder these because I like my x terms to come first. So I'm going to write negative 2x plus 12. And then my width, again, I'm going to reorder that. Negative 2x plus 15. You don't have to reorder it now. You could wait till the end and then put things in standard form. Okay, this way it'll come out in standard form if you reorder it now. And then I need the height. And we decided the height was going to be that amount we cut off. So it's going to be x. So I'm going to go ahead and do my multiplication. Again, I have 3 things that I'm multiplying together, but I can only do 2 at once. So I'm going to do these 2 binomials together first. So I've got negative 2x times negative 2x, or 4x squared. Negative 2x times 15 gets me negative 30x. 12 times negative 2x is negative 24x. And 12 times 15 is 180. Okay, and then I'll combine like terms here. So I have 2 linear terms in this thing that I can add together, these 2 negative numbers here. So that gets me negative 54x. Okay, and now I can actually multiply everything by this x to get the final expression for the volume. So that's going to be 4x cubed minus 54x squared plus 180. So there's my volume of my box. And I have to restrict the domain because we're dealing with a real life situation here where we only have so much of this piece of metal that we can use. And so the domain here, because I'm cutting off 2 of these things, one from each side, I have to take into account that there's 2 of them. So if I did 15, I could cut off 7.5 from this side and 7.5 from that side. That would add up to 15. But if I did that to this side as well, those 7.5s would overlap. So what I really need to do is look at the smallest dimension I have, which is the 12, and think about half of that smallest dimension. So my domain is going to fall somewhere between 0, because we're talking about positive real numbers, or all real numbers basically, but because we're talking about this metal, it has to be greater than 0. And my x has to be less than half of that smallest dimension, which is 6. So that's going to be the domain of this. All right, so the next question. this is an example of what a table would look like on a calculator if we entered certain equations, okay? We don't need to know what the equations are to answer this question, but what we want to pay attention to is these two columns on this table, and then we'll pay attention to these two columns on this table. So it says, based on the table below, determine the number of zeros and where the zeros would be. So what we're going to do is we're going to go down the Y column and see where 0 falls. So I'm looking at the Y column and I only see 1 0. Okay, but the problem is that there's more there. We're counting by integers here. And so we actually do have some zeros falling somewhere in between some numbers. We have one falling exactly at the point 0, 0, which is great, but we also need to find out where they would fall in between. And what you have to think of is your number line. Your number line, as you move from a negative number to a positive number, somewhere over in there you crossed over 0. So we know one of our zeros falls between -2 and -3. We know one of them falls at 0. What I'm doing is I'm getting the x values for where they fall. And then if I look at that sign change again, it looks like those are the only two I have. I went from a positive to a negative here, but I actually showed the 0. So I'm only going to get 2 zeros on this one. So it looks like 2 zeros here. Okay, and one falls between -2 and -3, and one falls at the number 0. So let's look at this table over here real quick. And we want to see, basically what you're looking for is in the Y column, you're looking for a sign change, because as we go from negative to positive, we would cross over 0. And if we go from positive to negative, we would cross over 0. So as I look down at these Y values, I see I go from -1 to +1. So that means a 0 would fall somewhere in between there. But then I also go from 1 to -1. That would cause another 0. I would cross over that 0 between those two again. And then there's actually a third on this one. When I go from -1 to +23, I would cross a third 0. So I have 3 zeros in this case, and they fall between the x values of -1 and 0, between, so that was this one, between 0 and 1, so 0 and +1, and then the last one falls between 1 and 2. So those would be your 3 zeros there. All right, next up. We need to determine the zeros to the nearest tenth. Whenever I see something that's telling me to round to a decimal, I know I'm probably going to be using a calculator for that. So what I did was I went into Desmos and I went ahead and graphed those equations. And because we're looking for the zeros, what that told me was I wanted the x-intercepts. So I went ahead and put my graph on Desmos, and there it is. You might have to do some zooming in or zooming out, changing your window to see it. But I clicked on all of my x-intercepts to get my values, and it says round them to the nearest tenth. So my zeros are x equals -0.5, +0.6, round that up, and 4.9. Okay, so I have 3 zeros on that one. And then for this one over here, I did the same exact thing. But this one only came up with 3 intersection points here. So I'm going to write x equals -0.3, 0.8, and 1.5. So this one also has 3 zeros. Now, we were expecting 3 zeros on this one because the degree was 3, and we got 3. But we were expecting 5 zeros on this one, and we only got 3. So that indicates that we have some solutions that may not be real numbers. Okay, they may be imaginary numbers in this polynomial. All right, so the next one, it says solve to the nearest tenth, but this time it doesn't say find the zeros. It set my polynomial equal to a number. You have 2 choices in this case. You could actually get this equation to be equal to 0, so subtract 6 from both sides. Or you could graph the polynomial that's on the right and graph the number that's on the left. And that's the way I did it here. So you will see that this curve here is my polynomial, my x to the third, my third degree polynomial here. But this line up here that I actually graphed was at y equals 6. So what I did was I found the intersection point of that, and I only had one intersection point. So my solution to this was 5.5. Okay, so looking for the x values because those are the y values up there. I did the same thing when I got to this equation. I graphed the polynomial, and then I graphed the equation y equals 3. Again, you could have subtracted 3 from both sides and then found the x-intercepts, and you would have gotten the same answer. With this one here, again, it looks like the same answer, but it's really not. It's a different window. You can see I ended up with only one intersection point here. So for this, I get an answer of x equals 1.3. It's said to the nearest tenth, so the 7 bumped the 2 up to a 3. All right, next up, this is that depositing money. So Mary is depositing money into her savings account that paid 6.5% annually. She made her first deposit on her 13th birthday of $100. Okay, so 13, we have $100. A second deposit of $150 on her 14th birthday. A third deposit of $200 on her 15th birthday. And the last deposit of $300 on her 16th birthday. And it says Mary made no other deposits or withdrawals to the account, and we want to find to the nearest dollar, we're going to remember that for later, what the total amount in the account is just after the last deposit. So that indicates that this $300 is not going to gain any interest. Okay, so I'm going to make a column here for how many years this money actually sits in the bank. Okay, so 3, it doesn't sit in at all, so I'm not going to put anything here. But if she deposited this $200 when she was 15, then it sat in the bank for 1 year from the time she was 15 to 16. This $150 sat in the bank for 2 years earning interest from the time she was 14 to 16. And this $100 sat in the bank for the 3 years from 13 years old to 16 years old. What's nice about that is that what that's doing is it's giving us our exponent. So I'm going to write the polynomial here. I'll start with the $100. So we have $100 sitting in the bank and it's earning 6.5% interest. So I'm going to do 1.065 because that's the amount of interest. That's 100% plus the 6.5%. And we said that's sitting in the bank for 3 years. So that becomes our exponent. And then I'm doing the 150 is earning the 1.065. And that's in the bank for 2 years. The 200 is in the bank for 1 year. I don't need to write that exponent. And the 300 is not earning any interest at all. So that looks like the polynomial that I'll be able to type in the calculator with that value in there. Just be careful with your entering to make sure you have plus signs between them. Okay, and if you go ahead and put this in the calculator and figure it all out, it comes out to $803.93, but because it told me to round to the nearest dollar, I'm going to actually type in 804 as my answer here. $804. All right, our next problem. We need to factor each of these and determine the zeros. Okay, so I looked at my first one and I said, well, it's not a difference of 2 squares because I have 3 terms here. And it's not a perfect square trinomial because 8 is not a perfect square. I also don't have a common factor that I can pull out first. So I'm going to go through the process of identifying what a times c is. A times c is 1 times 8, so that's 8. And b is -6. So I need to come up with 2 numbers that if I multiply them together, I can get 8. And when I add them together, I get -6. And the 2 numbers I was able to come up with was -4 and -2. -4 times -2 is +8. -4 plus -2 is -6. So I'm going to do factoring by grouping here, and I'm going to replace the -6x with these 2 numbers I just got. So x squared minus 4x. I'm going to go ahead and do this plus a -2x, so I don't lose that when I group things. And then plus 8. Okay. And when we regroup, We group the first two together and the last two together. So now I look for a common factor in the first two, and I see that there's an x there. And so that becomes x minus 4 when I divide out that x. And if I look at my second factor, I'm actually going to pull out a negative 2 in this one. And that leaves me with x minus 4. And I'm all happy because I got x minus 4 for both of them. So that's my first factor. And my second factor is the common pieces that I pulled out, the x and the negative 2. Now, I need to determine the zeros. So here it is in factored form. That was kind of step 1 of the problem. Now I need to take each one of these factors and set them equal to 0 and solve for x. So x minus 4 equals 0. Add 4 to both sides. It gets me x equals 4 as one solution, or 0. And then I'm also going to set this one equal to 0, x minus 2. And then I'm going to add 2 to both sides, so x would equal 2. So I found the zeros, found the factors, and I found the zeros. The second one here, I noticed that it is the pattern of the difference of two squares. So I know that is always going to work out to get me two factors. One has a plus sign, one has a minus sign. And the first term in both is the square root of x squared. So it's just x. And the last term in both is the square root of the 49. So that's 7. Okay, so there's my factored form. If you recognize that pattern, it's a nice little shortcut. Then I'm going to take each one and set them equal to 0. And that gets me x equals negative 7 as one solution. X minus 7 equals 0. I'm going to add 7. So that gets me x equals positive 7 as the second solution. Now I'm going to factor this third one here. What I notice first is that it does have a common factor in it. Each one of these terms has an x, so I'm going to go ahead and factor that out. And it leaves me with x squared minus 9x minus 11. So what I need to do is come up with two numbers that multiply to negative 11. Why I put 11, I'm not sure because I just changed it. It should be minus 22. I think I was thinking of the two numbers already. And add up to negative 9. The first things that come to mind when I see the negative 22 is a 11 and 2. And if I make that 11 negative and the 2 positive, when I add them, I will get negative 9. So I'm going to factor by grouping here. I've got x squared minus 11x plus 2x minus 22. Okay? And I'm going to group these first two together and the last two. Pull out a common factor. This x just keeps traveling along with us. The common factor in the first two terms is x, and that leaves me with x minus 11. The common factor in the last two terms is 2, and that leaves me with x minus 11. So it looks like that's my first factor. My second one is going to be x minus 11, and my third one's going to be x plus 2. So there's my factored form. I'm going to set each one equal to 0. So x equals 0 is my first one. X minus 11 equals 0. That gives me x equals 11. And x plus 2 equals 0 gives me x equals negative 2. All right, so there's my zeros. My factored form and my zeros. Okay, let's look at the next slide. We're still factoring. If you did the guided notes or you printed out the review on your own, there was a typo. There should be a plus sign in here in this third problem. So anyway, I'm looking at this very first one with 100 on it, and I noticed that 100 x squared is a perfect square, and 49 is a perfect square. So I'm pretty sure this can factor into the binomial square, the perfect square binomial, by taking the square root of 100x squared, which is 10x, taking the sign of the middle term, which is plus, and the square root of the 49, and that's 7. Now I'm just going to check and make sure this works by doing 10x times 7. That's 70x, but I have to double it, and that would give the 140x. So it does work. That is our factor. So I'm going to take that factor and set it equal to 0. So 10x plus 7 equals 0. We'll subtract 7 from both sides. So that's -7 and divide by 10. So x equals -7 over 10. That's my 0. And truthfully, that 0 has a multiplicity of 2 because that factor showed up twice. This one here, I don't see perfect square with 60. I don't see a common factor that can come out. So A, C equals -60 and B equals -4. When I see that 60, the first thing that came to my mind was 6 and 10. And yeah, if I make that a -10 and a +6, if I add those, I will get -4. I'm going to rewrite this. X squared minus 10x plus 6x minus 60. I'm going to group my first two and last two and pull out a common factor in these first two, and that's x. And a common factor in the last two is a 6. And we ended up with that same factor. So our first factor is x minus 10, and the second one is x minus 6. So there's my factored form. And I'm going to take x minus 10, set it equal to 0, add 10 to both sides, and I get x equals 10 as 1, 0. X minus 6 equals 0, add 6 to both sides, and we get x equals 6. And for this last one, I see a perfect square with 4x squared, and I see a perfect square with 9. So I'm going to use my binomial square. So I'm taking the square root of 4x squared, that's 2x. I'm going to pick up the sign of the middle term, so that's minus. I'm going to take the square root of the 9, and that's a 3. Okay, and let's make sure if I multiply them together and double the result, I should get -12x. So -3 times 2x is -6x, doubled is -12x. So I'm going to go ahead and set this factor. This is my factored form now. I'm going to set that equal to 0, add 3 to both sides, and divide both sides by 2. And there is my 0. And that 0, again, has a multiplicity of 2 because that was 2 factors that looked exactly the same. Okay, next up. Now we have graphs. We need to determine the zeros. We will write the factors, but then we're also going to rewrite it into standard form. All right, so the first thing I have to do is figure out what my x-intercepts are. So this looks like it's an x value of -2. And this looks like it's an x value of 4. So I'm going to write the factors that match those. So my first one is going to be, if my zeros are -2 and 4, then my first factor is x plus 2. Because if I substituted in -2 plus 2, I would get 0. My second factor is x minus 4. Because if I substituted in the 4 minus 4 would be 0. So I wrote it in factored form like it asked. Fabulous. And now I'm going to rewrite it in standard form, which just means I'm going to multiply together. So x times x gets me x squared, x -4x, 2 times x is 2x, and 2 times -4 is -8. And I'll combine like terms, x squared minus 2x minus 8. And there it is in standard form for you. So first identify the zeros. This one and this one. This one looks like -2 and this one is -4. So -2 and -4. The factor that's created with -2 is x plus 2. Because if I add those two numbers together, 2 and -2, I get 0. And x plus 4. Okay, so there's my zeros. There's my factored form, and now I'll multiply them together to get the standard form. X squared plus 4x plus 2x plus 8. Combine like terms, I get x squared plus 6x plus 8. And that's my standard form. I think we have 2 more of these graphs to do. All right, same thing. This time I'm actually getting more than 2 though, okay? So I've got this one, looks like it's at -3. This one is at 0. And the last one is 1, 2, 3, is at positive 4. So my zeros are at -3, 0, and 4. So the factor that I get from the -3 is x plus 3. The factor I get from 0 is just x. And the factor I get from 4 is x minus 4. So zeros, factored form, and now I'm going to multiply it together. I'm going to multiply the first two together. So that gets me x squared plus 3x. And now I can multiply it by the last factor. So x squared times x, I'm getting x cubed minus 4x squared plus 3x squared minus 12x. And when I combine like terms, I get x cubed minus x squared minus 12x. Okay, and for the second one, this is at -3. This is at 0. This one's at 2. So my zeros are -3, 0, and 2. The factor I can write from the -3 is x plus 3. The one I get from 0 is x. And the one I get from 2 is x minus 2. That's the factored form. I'm going to do that multiplication of the first two. I get x squared plus 3x. And now I can multiply that by the x minus 2. So I get x cubed minus 2x squared plus 3x squared minus 6x. And I can combine like terms, plus x squared, because those two add together, minus 6x. And there it is in standard form for you. Okay, so the next one, hopefully you definitely did the next couple by yourself before, not this one, sorry, I'm thinking of the finite differences. So for this one, we need to determine how many zeros there are. That's done by looking at the degrees. We figure out what the zeros are and state any multiplicity and the type of each, whether they're real or imaginary. So the way I figure out the number of zeros is I count how many x's there are. There's an x here, but there's actually two of them. So that's 2 x's. There's one here, and there's an x here, but that means actually 5 of them. So this factor gave me 5 plus 1 plus 2. So that was 5 x's, 1 x, and 2 x's came from there. So that means there are 8 zeros. Okay? And if I look at each individual factor, I can find out what those zeros are. That would be x equals positive 3, x equals negative, I'm just taking 2x plus 4 and setting it equal to 0 and solving it. That should get you negative 2. And the last one is positive 7. These are all real numbers here. Okay, so they're all real. That was the type, and I need to state the multiplicity. So x equals 3 has a multiplicity of 2. X equals negative 2 has a multiplicity, you really don't even have to say this, but of 1. And x equals 7 has a multiplicity of 5. All right, so looking at the second one here, this one gives me 4 x's. That's 1 x there, and that's 1 x there. So I'm looking at 6 zeros. Okay. All right, and if I find out what they are, I can list them. It looks like they're all going to be real numbers. I don't see any imaginary here. All real numbers. Okay, and for my first one, x equals negative 2. It has a multiplicity of 4, because that factor shows up 4 times. X equals negative 4 has a multiplicity of 1. And x equals positive 1 has a multiplicity of 1 as well. This one down here gives me a little bit of trouble when I get to that second factor, but we'll work through it. It won't be an issue. So this first factor, I see 3 x's, and in the second factor, I see 2 x's. So I'm saying there's going to be 5 zeros. Okay? This one's pretty self-explanatory. I'm going to say that they're, well, I don't see any imaginary, so I'm going to say they're all real. Okay? X plus 2, so the 0 there is x equals negative 2, and it will have a multiplicity of 3. But when I look at this second factor, x squared minus 9, can't really, you might be able to, but some people can't do this one in their head. So set it equal to 0. Add 9 to both sides. X squared equals 9. And then I need to take the square root of that to solve this. So x would equal 3 and negative 3. Okay? Because I got 2 answers out of this factor, it took up the 2 of them. So each one of those only has a multiplicity of 1. Okay? We have a multiplicity of 1, and x equals negative 3 also has a multiplicity of 1. And there's our 5 that we were expecting, 3, 4, and 5. All right? So we needed to determine the total number of zeros and how many are real and how many are imaginary. Now what I chose to do with this one was graph these because I couldn't even imagine factoring something to the 5th degree and the second one is to the 6th degree. So I went ahead and graphed it, and then we're going to interpret what the graph tells us about the zeros. So here are my graph. The total number of roots or zeros. I'm actually only seeing 3 on this one. Okay? I see 3 zeros. Okay? And then how many of them are real and how many are imaginary? Well, I have 3 real zeros because that's what showed up on my actual graph here. So I could say 3 real zeros. But truthfully, I was expecting 5. So if there's only 3 real ones, what that tells me is that there's actually 2 imaginary zeros. So when I only have 3 x-intercepts, but I'm expecting 5, the remainder of those have to be imaginary zeros. So I'm expecting, on this one, I'm expecting 6 altogether, right? So let's see how many we actually find on the graph. We find none on this graph. So there are 6 zeros, but they are all imaginary. All right. Now we will go to the finite differences. We need to determine what degree this model, this set of data will actually be when we write an equation for it. And the way we're going to do that is we're going to do repeated subtractions for it. Okay? So I'm going to do 0 minus negative 5, and that gets me 5. 23 minus 0 is 23. 82 minus 23 is 60. Oh, that's not right. 82 minus 23, I wrote down the wrong number there. That could be what was causing my issue. That's actually 59. I had these written on paper, but I just caught one of my mistakes. So, and I'm doing 195 minus the 82 is 113. And 380 minus the 195 gets me 185. And 655 minus the 380 gets me 275. So I didn't have matching numbers there, so it's not linear. So let's go to the next level. 23 minus 5, we're getting 18. 59 minus 23, we've got 36. 113 minus 59 is 54. 185, couldn't even read my own handwriting there, minus the 113 is 72. 275 minus the 185 is 90. Okay, so now when I do the subtraction, 36 minus 18 is 18. Ooh. Now I didn't stop here because those numbers didn't match, so it's not quadratic, but maybe it's cubic. 54 minus the 36 is also 18. That's promising. Keep going. 72 minus the 54 is 18. That's very good. And 90 minus the 72 is 18. And because it took us not one, not two, but to the third set of differences, we're going to say that it is going to be a third degree, or another name for that, of course, is cubic. I'm going to do the same thing with the next ones. Just be careful with these negative signs, and sometimes they confuse us because we're trying to do minus a negative. Okay? So, on our first row, we have -1 minus -5, and that gets me 4. -1 minus -1 is 0. -5 minus 1 is -4. -13 minus -5 is -8. So these definitely don't match here. -25 minus -13 is -12. And -4 minus -25 is -16. But I'm seeing a pattern in that. So I have a feeling it's going to be the next row. So 0 minus 4 is -4. -4 minus 0 is -4. -8 minus -4 is -4. -12 minus -8 is -4. And we have another -4. So we didn't find linear, but we did find it on the second line, which says it's the second degree, or we could say quadratic. So let's do this last one down here. We're going to do -13 again. Watch your negative signs. This gets me -3. -12, that gets me a +1. That gets me a +5. That gets me a +9. And a +13. And a +17. When I do this subtraction, I get 4. Oh, this time I'm getting +4s. It's not really going to matter what we get. What we're most concerned with is how many times we had to do a row of subtraction in order to get it to match. Right here, it didn't match for linear, but it does match for the second degree, which tells me it's quadratic. All right, the last thing we're going to do, the last topic we're going to do is division, and we've got 2 of those. Okay, so we're going to divide these 2 polynomials. I'm going to set it up first. I'm going to have p minus 5 outside, and I'm going to divide that into p cubed minus 10p squared plus 20p plus 26. And I just focus in on that p. And what do I have to multiply that by to get to p to the third? Well, I'd have to multiply it by p squared. So I'm going to put p squared up here, and I put it above the term it matches. And I go ahead and do the multiplication, but I have to remember I'm subtracting this. P squared times p is p cubed, and p squared times -5 is -5p squared. So I am doing p cubed minus p cubed. That goes away. Great. -10p squared minus negative. Oh, that means I'm actually adding. So this is -5p squared. And I bring down the next one, so that's plus 20p. Now, what do I need to multiply p by to get to -5p squared? Well, I need to multiply by -5p. So again, I'm going to subtract this whole thing. When I do this -5p times p, it's -5p squared. And -5p times -5 is positive 25p. So when I've done this subtraction, it cancels out, which is great. 20p minus 25p is -5p. Bring down the next one, which is plus 26. P times what is -5p? Well, that's -5. So I'm going to do that multiplication to figure out what I'm subtracting. -5 times p is -5p, and -5 times -5 is positive 25. So when I do my subtraction, this cancels out, and 26 minus 25 is 1. So my answer is p squared minus 5p minus 5 with a remainder of 1 over p minus 5. There's my answer here. Okay, and then I'm going to go ahead and I should be able to take that remainder of 1 and put it back into my original expression. And use the remainder theorem to check myself. I'm going to go do the next division. I'm dividing x minus 4 into x cubed minus 5x squared minus 32x minus 7. I'm going to do the same process. I'm going to go a little faster this time. So I'm thinking this should be an x squared. So I'm subtracting x cubed minus 4x squared. That gives me a negative x squared, 32x. So then I need it to be a negative x. So that gets me negative x squared plus 4x. So that gets me negative 36x. I'll bring down the negative 7. So I need a negative 36 up here. So that gets me negative 36x and did I do that right? 100 and I don't think it should be that large. Oh, it's not. Oh my goodness. I go all the way back and catch a mistake I made. I'm sorry, guys. The mistake I made came all the way up here. When I copied the problem, I copied the plus sign as a minus sign. That should be a plus sign. Okay? So I'm still multiplying by the x squared. That was fine. But the problem came down. Now I'm actually adding these two together. So it's 9x squared. My fault. Thank you. 32x. Okay, so now I'm going to multiply by a positive 9x. So that's going to get me 9x squared minus 36x. When I do that subtraction, I'm actually going to get 4x. This is a lot better. Minus 7. Okay, and then it looks like I'm going to have to do a plus 4. That's what I get for trying to go faster, right? All right, so then I have a 4x minus 16, and when I do that subtraction I get a remainder of 9. Okay, so I'm seeing my answer as x squared plus 9x plus 4 with a remainder of 9x over 4. There's my solution. Okay, so if you've done all of that, you did it all on your own first and made sure you were studying and not just copying the work, then you should end up with a decent grade on the test. So go try and find some other materials to study from till you have to take it.